Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hey, welcome everybody. Welcome to SkyTour livestream. Again, it's a great night tonight, and we have a beautiful sky out there. It's not quite dark, as you can see, evidenced by the all-sky cam here. You can see this is this area over here on the right. This is the sunset, the western horizon. This will get darker. You can see the Milky Way. That's what's nice about this site. Even before the sunset orange is gone and you see the orange of sunset, you see the Milky Way. It's just beautiful, absolutely wonderful. And my buddy Matt used to work here actually with me. That's Water Rat. How you doing, Matt? Nice to see you, brother. And we got SkyTour Live Fan 222. Hi there. I think that's Evan. I think if that's Evan, make sure you confirm that for me. Fantasy's with us already. But Tim F was the first one. Finally, Tim, you made it. And Michael Galea was just behind you. Good to see you guys, you know. Yeah, right. And Carl Becker is joining us again. That's good to see you. Might be a good idea, huh? You guys, of course, know Daryl, who's with me. Hey, Daryl.
Hey, Mark. How are you? Hello, everybody.
We're doing okay. So, as Daryl said, Scooby snack for Tim.
I'm nominal, thank you.
Nominal.
Warp engines are online.
Yeah. All right.
Marianne is here.
Hey, Marianne. I know who she's with. She is with Randy and Diane up in Pine Top, Arizona. Hey, Randy. Hi, Diane. Nice to see you guys, or hear from you guys. And nice to see Marianne as well. As everyone knows, Marianne is 1/3 of what makes SkyTour run in the background as far as a nonprofit organization. And then, Daryl and I just plug away. We're just the hired guns. So, we're hired guns for no pay, but that's just the way it works.
I wish I had some ice cream.
Who's got ice cream? Oh,
Randy.
Oh, really?
I bet Marianne has some too.
Oh, man. Yeah, maybe so. Wow. Kim Libby's with us. Hi, Kim. How are you? Nice to see you. I don't know if we've seen you before. Maybe you lurk like some of the other folks. You lurk and just watch. If you haven't subscribed, make sure you subscribe. We're waiting for it to get dark so we can look at this object right here. Let's see if our annotator can tell you what this is. No, it doesn't know it. So the Lens Dark Nebulae, or LVN, Lens Bright Nebulae objects may not be in this database. But look over here, this other faint patch right there, that's a globular cluster, magnitude 11.05.
Go
ahead.
I'm sorry, if this works, you should look at Messier 5 tonight. It's in Ophiuchus, I believe. It's a very nice globular cluster, and I don't recall ever doing.
I think we did. Okay, but that's a good idea. If this works, we will. Hello there, Dean Bastador. What's going on? And Marianne is going to be heading into New Mexico on Friday to look at a possible spot for a new observatory that we're going to be putting in. We have another option in southern Arizona, actually in Benson, as well. And we're just looking forward to consolidating our telescopes and having them all in one place. Benjamin Izabela, how are you, man? Mr. Benjamin Izabela's with us. He says he always loves hanging out. That's fantastic. Judy M is with us. Nice to see you guys. We're waiting for it to get dark. Again, as you can see in the all-sky camera here, it's a little bit light over here. This is the western horizon over there. Right, so that's what this light is here that you're seeing right here. This bright light. That's the western horizon. This right here, this is the lights of Phoenix, about 75 to 80 miles away from us in the observatory. And you can't really see that light very easily with their when it's dark out there. But if you have a sensitive camera, it's obvious. Yep. And SkyTour Live asked, what music do you use? Well, the opening song was one that I wrote and composed. It's actually, I picked all the instruments and set up the arrangement, and then I let artificial intelligence actually play the instruments, basically. Yeah.
AI is the devil.
You know what? I used to compose and write my own music, and for real. And I have keyboards, and I have guitar and other instruments, and I actually played them all to make my pieces and songs. But the trouble was that it just took too long, and now it's a utility item and not a necessity. I don't do that to make money, So I do it in an expedient way, but I make sure that the sound is what I want, and the tone is what I want, the voices are what I want, all that stuff. So this music you hear in the background, this is the YouTube music that you can go up on YouTube and grab, and I will actually go out and get new music from time to time, and I've done that in the past. I have a different set of music right now. If I could actually put this out, here's another set of music I have, and I'll leave this on for a while and see how that sounds.
I have a question.
Yeah.
How do those music reviewers get away with playing complete songs on YouTube?
Oh, they probably have to get permission from the songwriter. They have to get their ASCAP permissions. Like our original song that we use, and we'll go back to from time to time, is the Universe is Calling You. And The Universe is Calling You is written by Rebecca Borneman. Rebecca Renfro Borneman down in Florida, and she gave us permission through her ASCAP license to use the song.
Okay.
Yeah, so that's why we don't get flagged on YouTube, because we have the ASCAP license permission.
Right.
These songs on YouTube that you get on the YouTube channels, and they're not the gallery, but they're songs. There's thousands of them, and you get these songs and use them, and you don't have any royalty issues or whatever. Yeah. This
like music.
Yeah, but a little more targeted. As you can see, this camera here has failed out in the dome, but it comes and goes. Out in the building, I mean. But not a big deal. I'm going to take it down for now. And that gives us more room.
Maybe Marianne tripped over a cable today.
No, she did not. We actually went through all this. Okay, Water Rat or Matt says a lot of YouTubers use copyright-free music so they avoid trouble. Exactly. That's what I'm doing. But guess what? I was using copyright-free music about a year and a half ago, and all of a sudden it became copyrighted. That's right. And YouTube started flagging every one of my videos. And it's like, oh, that's insidious. You know, this music company just decided, well, we're going to renege on our agreement and make everybody now pay us. And they tried to do that, and I simply wouldn't. And I think a whole bunch of others didn't, so they abandoned that approach. But not a problem. There's always a way around it. Alright, so we're still waiting for it to get a little dark. Well, let's just try an exposure with this. This will be, I'll put it in here anyway. It's LDN 7, LBN, I mean, Lynn's Bright Nebula 7, so it's going to be LBN 7. Alright, and it's a Bright Nebula. We'll say EN RN for emission nebula, reflection nebula. Then
Hopefully it'll be two nebulas in one, a light one and a dark one.
I hope so. But this is LBN, right? Not LDN. Am I wrong? Let me check that out.
No, LBN's the bright one, and LDN is the dark one in front of it.
Yeah, which LDN is it?
I forget. Let me look real quick.
So, yeah, this is LDN 7 that I'm in front of. So, that's the one we're looking at right now. So, just to be proper here, I'm going to say LDN 7. Well, not like that, I won't.
LDN 43.
Oh, okay.
The dark one is 43, the bright one is 7. Both discovered by Mr. Lind, I guess, or
now look,
signed up in his catalog at least.
7 is the dark nebula. See, it says LDN 7 right there.
I don't know.
So if you see it wrong differently, then somebody's wrong. Somebody wrote it wrong.
I checked several sources. They said the dark one was 43 and the bright one was 7.
No, look at this. Dark nebula, LDN 7. So we'll see.
Stellarium.
Yeah, that's true. Stellarium isn't well known for its proper names either. Alright, let me go back here and just check something. We're looking out here right now. Kind of just out here. So there's no clouds. You can see more and more stars out there. That's beautiful. And this is a 15-second exposure. I could make it much darker by shortening the exposure, but, you know, I'm not going to do that. No need. All right. So let's minimize this guy. And we'll try exposure. We're going to do 12 seconds just to start. And we have a 12-second exposure. You can see it over here. When we set our exposure right here in that field by the red arrow. And then we set our gain, which is the sensitivity of the sensor, here. Gain is at 200, and the exposure is at 12 seconds. So let's give that a shot and see what it looks like. And we'll get out of our low light mode here, which kind of looks green. And we'll go into our live stack mode, which is our deep sky mode.
He's here.
What's that?
Tiffany is here.
Oh, Tiffany. Hey, Tiff. How are you? Nice to see you. All right, let's see what... Let's first of all color correct, bring all our curves under each other. And let's do this. Yeah, I can see that there's a nebula that's going to be here. This noise you see here... Wow, there's a lot of nebula here. Look at this. It's everywhere.
I suspect that's the dark nebula right there.
Yeah, that's pretty amazing.
It's sitting right on top of the bright nebula.
It is. All right, we're going to bring our... do a higher res on the curves here, high resolution. When it gets darker, this will be a beautiful object to check out. Right now, the red we're seeing is from the sunset. And we're going to get rid of the color noise. So watch now. Boom. It immediately gets better.
There's that globular on the right.
Yeah, that's right. And a satellite right there. Wow. So as it gets darker, these will look much, much better. And that's what we're looking forward to. We want to make sure it looks better.
I'd like to answer Benjamin. Benjamin, I saw recent stories about Betelgeuse possibly being a double star. The secondary star is actually inside the atmosphere of Betelgeuse, I believe.
Oh, that's right.
Whether that would preclude it still becoming a supernova or not, I don't know. Might still happen. Might get 2 supernovas for the price of one.
That could be very interesting.
Yeah, probably not in the reality, though. What might happen if Betelgeuse blows, that the secondary might get cut loose and start flying off across space.
Well, we'd have a star. And actually, that's one theory as to how some of these stars have been propelled so fast as that they were ejected during a supernova event.
Yep.
Yep. SkyTour Live fan, did I miss a question from you? Brand new photo with name. What's that? Just looking here what you said, because you're saying never mind now. I'm going to find out what you said. Yeah, thanks for that question, though, Benjamin. That was a good question. All right. Yeah, so even though it's not even quite dark yet, look at this. We're seeing this dark nebula. This is going to be a really pretty shot. And it's framed rather nicely because we got this bright section in the middle here. And then we'll have the dark nebula all around it. That's a beautiful object.
I'm curious where the bat actually is.
The cosmic bat?
Yeah. What we're looking for is called the Cosmic Bat Nebula, folks.
Oh, we looked at this before.
Have we?
Yeah.
Okay, well, I don't remember. Anyway, there's like a dark bat superimposed in front of the bright nebula behind it. And it looks quite bat-like in images I've seen.
So, is this supposedly the Cosmic Bat Nebula then?
LDN whatever 43 is the actual Bat Nebula.
Okay.
LBN 7 is the Bright Nebula around the Dark Nebula.
Well, Stellarium either has it wrong or, you know, what you're looking up is wrong. So, you said LDN 43?
I believe so, yes.
All right, let me just. I should see. Actually, let me look it up as Cosmic Bat. I think it has that. Here it is, Cosmic Bat Nebula. Yeah, Cosmic Bat Nebula is not up right now. That's the Fox Face Nebula. Yeah. So, we're up here somewhere now. Or is it just a Bat Nebula? Are you muted?
Whoops, yes I am, sorry.
Okay. That's fine.
No, they called it, again, several sources, they all said Cosmic Bat in Ophiuchus.
Okay.
Ophiuchus is the serpent bearer, folks.
Cosmic Bat Nebula here is brings us way down below the horizon. There's something that's not
I know.
Yet. All right. Let me look up LBN 43 and see what that is. Oh, I think I just said GC 6589 LBN 43.
Oh, it's LDN.
Yeah, I know, but
43.
I was just seeing if the opposite was true.
Yeah, that was a great Sagittarius star cloud there, wasn't it?
Yeah, and to the folks that were actually no one was with us yesterday. I was actually doing this on my own. I did a mosaic of the Sagittarius star cloud that I'll make available to everybody. Okay, let me clear this now because I have to take advantage of the fact that the sky is a little darker now. Hey Genghis, what's going on? Trisha, how are you? Alright. This is beautiful.
We've seen mistakes in Stellarium before.
Oh yeah. Yeah, I don't doubt it.
Can you go back to Stellarium to where we are?
Yeah.
Zoom in a little bit, see what it says.
Let me go back to LDN 7. Because that's what it thinks where we are. And it's not going to show anything because it's a dark nebula they don't show in here.
Try LBN 7.
Alright, let's see what it thinks LDN 7 is. Turn the music down a little bit. Right, LBN 7. Let's see here. Alright, LBN 7, where are you? That's completely somewhere else. Ophiuchus, but completely somewhere else. So LDN 7 is this location here. Can I understand it, Captain? It is what it is. Alright, so now let's get the colors. There we go, a little color correction. Let's work the levels a little. And now we'll move this over. Beautiful. Pascal Lapierre, how are you? The capture software we're using is SharpCap, the latest version. And we're controlling the telescope with APT. We are running Arduino Unos to manage the background stuff using the software that I had to write for the observatory. And so that's the housekeeping stuff, turning on power, making sure you can't, close the building while the telescope's pointing up in the air and that kind of stuff. Well, this provides us a lot of functionality. Like we can have this filter. This is a filter called a full width half maximum filter, and in astronomy we use that quite a bit because we only have the light to look at. So when we look at the light, we want to be able to get really nice, beautiful, perfect star images. To get these perfect star images, we have to make sure they're nice and round. So what this filter does is it assures us that the stars are going to be round. I want to say hi to Rocket City Astro, who's just joined us, and Josh Rutledge is with us. That's Mystical Experiences. I've known Josh for a long time. Josh, let me just show you while you're looking. Here is our all sky, and you see all the stuff I have on the screen here, Josh? That stuff is all stuff you can insert, right, and put into your screen rather than the basic stuff. And then this is the website, and look what you get. Okay, if you calibrate it all, you can actually put the constellations up, show people the constellations, so forth, right? This is time-lapse video from days before, and we're still waiting. We're capturing stuff. Here's all the time lapses that I put in. This is last night's, and you'll see there's the moon going down, the sun's coming up here, and then as the sun goes down, okay, the stars come out to play, and you see meteors. You saw a flash right there, meteors, and there's some satellites going by. This is really good to actually capture and study all the satellites and meteors that we see. Look at all those. Really cool. Those are probably all Starlink. These are artifacts just because we're asking it to do an awful lot right now, and I'm going to go to better quality. There you go. So there you go. And then it's at the time here is 11:30. So by 11:30 at night out there, look, the Milky Way is already setting, and the moon is coming up. Here comes the moon. Yeah.
Oh, the southern Milky Way is setting. The winter Milky Way is just rising.
It's just coming up. Yeah, that's correct. Yeah, Oh yeah. So this is beautiful, and by the way, this is a last quarter, just past last quarter moon. So that we're looking at, and because the camera's so sensitive, it blows everything out, as you can see. And now it's 4:17 in the camera, and we'll start to see dawn approaching, at which point the camera, there goes the satellite, and here comes dawn from the east, and that's it. And then it just resets to back there. So the time lapses are beautiful, and we also, with the all sky camera, we get what are called kiograms. These are interesting because what kiograms do is they give you a glance at the night, just one glance like this, and it shows us this is the day, and what those vertical lines are the time slots. So every hour, 7, 8, 9, 10, etc. And as the night wears on, you can see that it goes all the way to 5 in the morning until dawn right there. So it shows you the quality of the sky during the course of the night. You see how it was. If there were any clouds, you'd see them in here. It's a little tiny strip, kind of an average of the hour. That's really kind of cool. All right. And then, of course, because it's just so beautiful, because people love it, we have star trails. It's cool to see star trails. And you wonder what these things are. These are planes going by. There's a plane right there. You know it's a plane because it has these extra little dots on it. And we can zoom way in, and you can see the extra dots. Those are the red belly strobes on the plane. Okay, so that's kind of cool. And then in here at a glance too, throughout the course of the night, you can see many of the satellites, and sometimes you can see as well a number of the meteors you might have seen that came through, because they'll be like bright streaks, and those are included in these star trails. But being able to see this many star trails is testament to how dark it is out there. Okay.
Benjamin, everybody should see the Milky Way from a real dark sky.
Yes.
People would have their minds blown. Who knows? It might even cause a shift in their consciousness.
Well,
most people don't care, though, which is sad.
I will say this. When I first looked at the sky out here in the desert, I was so blown away by the Milky Way and the sheer brightness of it that it actually overwhelmed me. And I literally had to sit down. I could not believe how dark it was. And the other thing is, because you're so far away from everything, I couldn't believe at all how unbelievably quiet it was. There was literally no sound, not a distant highway. Nearest highway is like 40 miles away, or more, and there's no street lights on the highways except near the cities. So it really was just incredible. It really was just incredible. All right, this is. I'm calling this LDN7, Daryl, but it's. I know that we're going to have to figure out the right name. So I'll save this. That dark stuff is actually dust from countless supernovae and from countless red supergiants that would expel their outer shells and liberate the outer atmosphere, which is many times molecules of carbon and cyanogen and CH, which is another common molecule. That's carbon with a hydrogen. It's just incredible. We'll say this exactly as seen. Hey, Roy Batty. Roy Batty is with us, straight from Blade Runner.
May we try LBN7?
Yes, we can. All right, so now, this is gorgeous. I mean, I just love listening to music that just plays like this. This is ambience. Great stuff. Okay. Okay, we're going to come out of this and go back to our low light mode, guys. And in low light mode, we'll see the sky is a little bit like a green, which is fine. I'll enlarge it. All right, and now we'll go to LBN. Seven. That's this one over here.
Yeah.
Okay. Let's visit LBN 7. You watch the telescope. You'll see it's gonna move a little bit more to the west. You see it go? And then here, we're way down toward the horizon here.
That's what I was afraid of. Maybe below the wall.
No. It's not below the wall. It's actually well above the wall because we're looking at the western one. And so we're good now. But I do have to take an exposure to make... Well, actually, wait a minute. I'm going to do a nearby search. There's no deep sky catalog objects in the view. Okay. It doesn't mean we're not looking at it. So let's do this. Let's give it a 10-second shot. That's 10,000 milliseconds. Sorry, not 100,000. All right. And we'll leave this here. We won't go into stacking. And we'll just look at this enhanced view. SkyTour Live says, play scary music, please. It's not Halloween yet. Okay, look, there's a nebula here. There's a dark nebula here. Alright, we're going to give this a shot. This one is going to go 25 seconds. I could say 25S or 25,000. Alright, we'll do that. And we'll come out of a low light mode and go into deep sky mode now. That's our previous shot that we took. And that will be up on the server. Every photo we take, guys, you'll see the green bar up here at the top here when the photos are taken. And we are sending those photos up to the server. They head out to space and come back down via satellite. Well, or look at those. Yeah, those are Starlink satellites. Quite bright. I mean, it looks almost like a geometric pattern. Okay. Daryl, let's try a different one. Instead of LBN 7, there's another one that I was going to look at that I looked up. It was LBN 43. This one is another one that's got some real beauty to it. Should we do that one? Because this isn't going to come out right now. Look how low the horizon is.
Yeah, okay.
Alright, so we're going to pop out of this. We'll go back. We're going to go back, boys and girls. And we're going to go to Lynn-Bright Nebula 43. It is a reflection nebula and an emission nebula. It's both. Like CERTs, it's 2 mints in one. 2 nebulae in one. Okay, so we'll come back here. And we're going to say to go. And you'll watch the telescope move a little bit toward the east. There it goes. Okay. And it'll get here, and it might pass a cluster. Alright. Look at that. That's pretty. Alright. Thank you for putting that up on the server, Daryl.
Sure.
I will now do another annotated view and see what's in the area. Yeah, there we are. It's here. It's in our view. So I can bring that down and move it over. And I'm going to head to the east a little bit. Center it up. This annotation works great. We've really, it just adds so much. All right. Now I did do a critical focus earlier. I'm going to zoom in and check the critical focus again. It doesn't look that bad, actually. Alright, so we're going to come out now, and we're going to do a 30-second shot here. 30 seconds, and we're off and running.
Can we see where we are in Stellaria?
Yep, I'm going to go there in a minute. So we're going to come out of this low light mode, go into deep sky mode, and clear that. Actually pretty cool abstract. Alright. So in Stellarium, we're in the middle of the Milky Way right now. We're near the small Sagittarius star club. And we're here.
Okay.
Yeah. It's actually a very busy area, as you can see. Look at that. That's beautiful.
Nice.
Oh yeah, it's really pretty. And there's more below here. So we'll center that right there.
So that's the small Sagittarius star cloud on the right
Yeah, and above, yeah.
and above.
Yeah. And now I'm going to... This one here is our dark level. And you have your red, your green, and your blue curves, which make up the image, RGB. And this white one is the average of all three. So when we do this, and we color correct, we line up all our curves under each other, you'll notice the color will change slightly on the screen. If we change our colors, we add, say, more red, you see how the curves separate, and then, of course, how red it gets. So we would color correct that, bring that red curve under the green, under the blue, and the color is more what it should be. And this average white curve tells us what the total number of curves added up where they belong. And this black level allows us to actually set a dark level. And as long as we don't cross that top peak, we will have a nice view. Okay, because the farther left we go, then the more sky comes in, the more subtle detail we might pick up, but it gets a little light. And so what we do is stay just to the left of the peak, right? Because that's the best darkness to signal size. And if we go over beyond it, well, then you'll notice we lose the nebula entirely. It's there, but we can't see all of it because of the fact that we're passing most of the data with our cutoff curve here. So this will put us right about there, just to the left. You look at these beautiful blue nebulae.
Yes. Two little reflection nebulas.
Yeah. This level over here is our mid-level. And when we do this, you'll see that the whole screen gets brighter. So if there's subtle detail, we can just bring this right over and see, hey, what's in there? And now you can kind of see what's hiding out in there. And then, of course, we'll bring it back to a more realistic location. I like this right here, and I'll show you why. Because within this this is all dark dust, actually. But the dust is actually scattering the blue light from these stars. And when they do, they make a region for some distance away where the dust that is surrounding these stars and within the stars, this dust is actually scattering the blue light only from the star. So that's why they look blue. And that blue appearance is precisely what we see in our own sky when the atmospheric molecules and atoms in our atmosphere do indeed scatter just the blue light coming from the sun. That's the reason why sunset is red and sunrise is red, because a lot of the blue light has been removed and scattered in all directions. And so we see that. And here we've got this little dark area right here, which I think is really interesting.
Yeah, I was going to say.
It almost looks like a globule. Now, Bart J. Bach was the man that coined the phrase Bach globule. There's another one right here. Okay. And these are areas where the dark material, this dark matter, not dark matter, but dark dust, is condensing gravitationally. And here, silhouetted against this blue reflection nebula, as they're called, you can see what looks like a globule that's in the middle of condensing and gravitationally contracting. Is that what's going on? Perhaps so.
Kind of hard to make out with the background noise, but I think I see several small dark ones to the right of those two reflection nebulas.
Like here and here and here.
Yeah.
All right, well, let's try another additional enhancement. Let's add an unsharp mask, which should sharpen up our detail a little, and it does. Alright, so we back out, you get an idea what the whole field looks like. You see, this black is not a void in the stars. This is actually the dark dust that's in our Milky Way. That's the thing that's that floors a lot of people that they don't understand. Because you're not seeing a void, you're seeing dark dust that's blocking this star cloud behind it. Okay, so that's up here, and those stars are way back here, and this dust is blocking it. We know this because we can detect the dust, by the way. Go ahead,
before we leave, we should goose it up and over just a bit to try to catch more of the star cloud.
Let's see where that would put us. Let's center it up again. Yeah, we're catching a little bit of star cloud here. But you're right.
Yeah, we're catching just the edge of it.
Yeah. Yep. And that's cool, and you can kind of see that immediately it's getting really dense up here. Right? But this dark matter here, this dark material, this dark dust is actually blocking what's behind it. Okay, we have 12 of these. And if we look at our filter, you'll see that we have one that was not good. For some reason, maybe there was a little gust of wind, and it moved the telescope. Because if you notice, this is like a giant flag on the end of the telescope, that shield. Okay, what you're seeing inside that opening of the telescope, that right there, that round thing, that's actually the camera. Let's see if I can zoom in. Okay, so if we show you this now, that's actually the camera inside the telescope. All right, it's on the front of the telescope. It's not on the back like most telescopes. It's on the front. And what this has done is it has given our telescope eyes that can see a much wider field than normal. So our field is 1.5 degrees across by 1 degree tall. And as I mentioned before, the camera is tuned specifically for this telescope to be the best overall image gatherer. And we already have the camera for the next telescope as well.
Don't forget to change your title for the image.
Yeah. It says LDN7 right now. This is LBN43. It's an EN and then RN for reflection nebula. There we go. All right.
Pretty picture.
Yeah. Dean Bustador, you're asking about why we have all these stars up here. That's, as Daryl had mentioned earlier, that's the beginning of the Sagittarius small star cloud. And where you see that in our planetarium is here. If we center up this square, this red square is our field of view. Okay. Actually, it's here. Okay. And the upper corner has captured part of this small star cloud. And that's what we're seeing here.
There's also a great Sagittarius star cloud. This is just a little one.
I know, that's right. The great star cloud is down below, and it's really low to the horizon. Last night I caught it and I did a mosaic of 8 separate frames to capture a good portion of it, but not all of it. And that was just to be able to make a mosaic of it. So we're up to 16 images here. The more we go with images, the better the image technically can look, and that's because we're actually we're trying to get rid of the noise that the digital capture process creates, and that's what we're seeing here. We zoom in, you actually see some areas that are a little, let me just do it, show you. See all that modeling? That modeled stuff? That's no good. And the longer that we take the picture, the better it's going to look. And so that's really cool. Absolutely.
So it reminds me of the last line from the original Battlestar Galactica's opening. Some believe that there may yet be brothers of man who even now fight to survive far, far away amongst the stars.
Mm-hmm.
And then the horns come in, if I remember right. Dun, 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 dun.
Fleeing the Cylon tyranny, ragtag fleet looks for, I forget what they say, but in the end, the destination is Earth. And then the show jumped the shark horribly when they went to Earth and were riding around on motorcycles.
Yeah.
Yeah, in the Hollywood Hills.
And then it was a kid's show, wasn't it?
Yeah, that's when they started running out of money. People knew the show was running out of money. As a visual effects guy, even as a kid, I knew it. They were running out of money when they started just reversing the plates of the Cylon raiders getting blown up by the Vipers. You know, you'd see one coming in, a laser blast comes from the left, hits it, boom, blows up. Then you see one come from the right and go to the left, and then boom, blows up. It was the same one, reversed. It's like, oh, okay, come on.
Did you know that both the original and the reboot of Battlestar Galactica are replete with Mormon themes?
Yeah, actually I heard that. I did hear that. That's an interesting, I guess you call it trivia point.
Yeah, Larson was a Mormon, if I remember correctly, and they kept it up big time in the reboot.
Yeah. Yeah. And Daggett was also a Mormon. a Mormon mechanical dog.
I hated that.
Me too.
It's like
it's all part of jumping the shark.
Oh, he was there from the very beginning, though, wasn't he?
I don't think so.
He was the robot dog of that
Boxy.
annoying kid, Boxy.
Yes.
And Boxy was the son of Jane Seymour, who was in the very opening episodes. And she was beautiful.
Yeah.
That was when she was still working her way up as an actress.
Mm-hmm. Okay, 24 exposures here. Let's go see. The moon won't be up for a while, so we have choice of stand. After this, where do we want to go? I have a few ideas.
Can we get up in the star cloud for a second?
Me here?
Yeah.
Like now? Because I'm in the middle of exposing. Well, actually, this is
the way you were talking about you were doing.
Oh, okay. Well, this is 25 exposures, so we can stop it there. Okay, and now what we'll do is I will move it straight up so that we can actually make a nice mosaic with this. So I'm going to put these stars at the bottom. First of all, get back to our 10 seconds here. These are going to have moved down a little bit. Or a lot of it. Yeah, they're already down here now. There's a star cloud. Let's just do a quick 10-second shot. We'll leave it on this here just to see what it looks like. Let's look at our night sky while we're waiting. Okay, so now we're looking good out there now. Yeah, so we have a dark rift here, and there's the star cloud. It's actually a little higher here. I think this is our nebula here, so we can go a little bit higher. So that'll be fun. We'll do that. I will move this guy up some more. Okay, there we go. And we'll do a 25-second photo of this as well. Alright, and here we go. Leave the low light mode. You know what, guys, it's amazing to think that every time we look at these stars here, we could be looking at life out there of some kind. Look like the Matrix, these perfect lines of stars here. That'll be in the image I gotta clear. Now let's get our next one. This is the Sagittarius star cloud. I think we lost that one because it wasn't quite, didn't quite find its guide star yet. But this next one should be good. Dean Bostador, Mork and Mindy. That's right. I remember Mork and Mindy. Oh, okay. We're waiting for this to level out. Nanoment. Give me a green. Alright, I'm gonna have to increase our threshold a slight amount. I'll go to 8.
And Mork had really hairy legs too.
Yeah, I wasn't looking at his legs.
When he tried out as a cheerleader.
Okay. Alright, we are... I'm gonna pull this up even higher. And we're at the point where if there's any wind blowing it around out there, it's gonna make it just a little bit oblong, the images, and we may see that. Cindy Murphy, how are you? Michael Hedrick, what's going on? There we go. There's the Sagittarius star cloud, and just below it, down here, just out of view, is the nebula. But some of this was in the view, so we'll be able to link them together. And that's a dark cloud in the galaxy, as is this one. And this is our first image. Alright.
Wind is it cooperating?
Yeah, it's got a little wind out there. I'll risk going up to 8.81 pixel shift. And most of the images should come in now. Okay. Let's go out and...
Can you back out a little bit? Or go full frame or whatever?
Yeah.
There was something up at the top.
Up there?
Yeah, that right there. Barely catching it. Looks like a concentration of stars.
Well, let's find out what it is. Okay, it's NGC. I can't even read it with this. I have to zoom in.
All the stars in the way.
NGC 66. Is it 6683? (6603). Oh, that's the Sagittarius. That's the small Sagittarius star cloud. Okay. Yeah, it's just the star cloud indicator. All right.
So is that little thing the actual star cloud? I thought the whole thing was a star cloud.
Yeah, the whole thing's a star cloud, but that little thing you were looking at is not known. But you can see the star cloud is going to be circled with this big thing. It's a big object, obviously, as you know. Yeah. So it's fighting something, but the last 4 have been good. The last 5 have been good. So I think we're able to do this and not have any oblong stars. Let's zoom in and see. Slightly, yeah, there a little bit. But talk about the firmament, boy oh boy, the crazy flat earthers, say that there's a dome over the Earth of the stars, and they don't even say, well, then how come in the southern hemisphere Orion's upside down? They have no explanation. Why in the southern hemisphere can't you see the North Star? They have no explanation. Why does the sun stay the same size going through the sky all day? If it's really a flat Earth, it should be small on the horizon, get larger as it comes over, and get smaller as it goes away. It doesn't. It stays the same size. They have no explanation. I've never seen a more blinded or blind group of people than the people that believe the Earth is flat. I think it's almost a sickness. And I can truly understand that people just don't understand science. Okay, that's one thing, and I have nothing against them, and I'll be happy to talk to them. It's the ones that push the obviously bad theories that makes me absolutely think that they can't possibly believe this. I think they're just trying to get people all worked up.
Everybody knows the world is really a disc sitting on the back of 4 giant elephants, which in turn are standing on the back of a huge turtle.
That's right.
Hopefully somebody gets the reference. Terry Pratchett's Discworld.
Michael Hedrick
Jim
says.
just got it.
Okay. Let's see. Michael Hedrick said, "Good grief, Mark! The number of stars here. Wow, absolutely, absolutely." Wayne Pinkham's with us. Hi, Wayne. How you doing? Every time you come on, Wayne, I always tell the story. Wayne went to Mauna Kea in Hawaii to the observatories, and he brought me back the coolest T-shirt I've ever seen. I still wear it, Wayne. It's an amazing T-shirt, and it shows the size of all the mirrors on top of the mountain, in different types. It's great. And then he got me Muamua postcard, which is really cool. Very thoughtful too. But that's Wayne Pinkham. He's a very thoughtful guy. Good to see you, Wayne.
Michael H., how do the photons even reach us and not get all cluttered with all these points of light? Those points of light are all very big, but they're very far away. They're all stars. Photons are tiny little things, smaller than electrons.
Well, the thing to keep in mind is that when you look at the stars here, they look like they're so bloated and almost on top of each other. But that's the sensor of the camera that makes them look bloated. The thing that's interesting about it is that they are points of light, tiny, tiny points of light. And these little points of light are literally smaller than a thousandth, even maybe 100,000th of a pixel of actual size. More than that, maybe 100,000ths or 200,000th or more. And depending on how far away the star is. And so they're so bright that those tiny, literally sub-thousandths of a pixel on the camera would be so bright that they would be piercing as a tiny little needle of light. So this is a false view of the universe with every camera we've ever taken pictures with. We've never seen the universe as it truly is. These stars look like they're on top of each other. In fact, if we saw them the way they really are, well, it wouldn't look so crowded. The stars would have definite separation between them. Okay.
When the photons are inside the stars, it's so dense inside the stars that it can take the photons like thousands of years to get out.
That's right. In sub-stars, it takes a million years. Sorry, Daryl, I didn't mean to step on you there.
I mean, like when the photon is inside our sun, it's not always the same photon either. I mean, it gets absorbed and re-emitted over and over and over when it's inside the star, inside the sun. What takes thousands and thousands of years to get out from inside the sun, once it leaves the surface, it only takes 8 minutes to get here.
And then to make matters worse for everybody, that photon, from the time it was emitted to the time it reaches us, its point of view is that it was instantaneously here. And that's relativity.
Because it's traveling at the speed of light. Time does not pass.
That's right.
So from the photon's point of view, I mean, it could be anywhere, everywhere, all at once.
That's exactly right. And the thing is, if you want to see when Daryl's talking about the photon getting hung up inside the star, let's talk about things that don't usually get hung up by anything, and that's neutrinos. Neutrinos are small high-energy particles that are coming at us, going through you by the billions all the time. Right? They go through the entire Earth almost unimpeded. We can capture a few of them in deep, deep mines that have these large tanks of special water and sensors to detect the passage of a neutrino through them. It doesn't stop the neutrino, but it just senses the passage. And neutrinos inside of a star, when they're emitted, neutrinos are emitted by the trillions from a star, and the only neutrinos that actually get out of a star because of all those collisions, as Daryl was mentioning, is like 1 in 1 billion neutrinos gets out. Even so, we see streams of billions of neutrinos that are coming out and heading to us from events like supernovae. Okay, when you see a supernova event, before the star actually visibly goes supernova, the neutrino stream reaches us. Because neutrinos are actually the thing that causes the star to go supernova. They play a major role, and it has to do with how they're trying to get out of the star. Only 1 in 1 billion actually get out, but more than enough of those get out. And there's so many of them that they actually will play a major role in disrupting the star. Okay, we're going to save this now. It'll be in the same directory.
Dr. Becky vid on Messier 5 I mentioned today in chat. I've seen it expressed several ways.
Yeah.
She held up her thumb. She said 65,000 neutrinos are going through her sun, through her thumb every second.
Yeah.
Just her thumb.
Yep, that's just the thumb.
This is a really good video. You should watch it.
Yeah, I've seen Dr. Becky do her thing. She's great.
Well, in particular, why they were looking at Messier 5, a globular cluster.
Yeah.
They helped solve neutrino energy and mass.
All right.
Doing a statistical survey of stars in Messier 5.
Yeah, that's the Rose cluster. It's too close to the horizon. It's already down, Daryl. So.
I figured as much.
All right. Okay. Well, this is cool. All right. Now let's come up here. And let's go to Albireo for a minute. Telescope's going to go way up overhead now.
Albireo's in Cygnus.
Yeah.
Cygnus is the swarm. Albireo is the head of the swarm.
Right there. It's a beautiful K3 star, so an orange star, but it's also a Roman numeral 3, which is the luminosity class, meaning is it a normal star burning hydrogen into helium, which is a Roman numeral 5 or a V, or is it a star that has stopped doing that and has moved off into its next level of evolution? And in this particular case, it's a star that has moved off to its next level of evolution. And so right now it shows as a K3, Roman numeral 3. K goes from, all the O, B, A, F, G, K, M stellar classifications go from 0 to 9. So G0 to G9, we're a G2. And our luminosity class is a V, a 5, meaning that we're normally fusing hydrogen into helium. So let's check this out. Let's move in on Albireo, this gorgeous double star. Okay, and we will.
The companion star is quite blue.
It is, and it's a B8, I believe. So it's almost a B9. So it's quite far from being an A star, which is the next one. A stars tend to be white, Okay, let's show you these colors. These are beautiful colors. And we'll do I think 10 seconds is all we need on this. And then we'll go out of this mode. Look at the beautiful colors, huh? And now we'll go into our stack.
So is the K star no longer on the main sequence then?
That is correct. When Daryl says the main sequence, he means the star is fusing hydrogen into helium normally, and this star here is no longer doing that. So it left the main sequence at some point in the past. Let's color correct first. Get our curves lined up, and now let's do an adjustment here.
So is it heading toward red giant phase?
Well, right now it's actually in that middle ground. It's a Roman numeral 3, so it's sort of like a giant subgiant range. The halos are from our system, by the way. I can remove those kind of quick here. So the star is no longer doing that. It may be burning and fusing some helium into carbon inside. And this star is still on what's called the main sequence, the blue one, the B8. It's still creating helium in its core. So here you see it, magnitude 5.12. It's beta 2, all right? That means that it's the second component of the second brightest star in the Cygnus constellation. Beta Cygni. Alpha Cygni is Deneb up at the other end, and Deneb is the rear end of the goose, swan, and Sadr is the Gamma Cygni. So we have Alpha, Beta, this one, and then Gamma, and they go in order of brightness, and they use the Greek alphabet. So Alpha, Beta, Gamma, Delta, Epsilon, Zeta, Eta, Theta, etc. Karen Belmont, hello.
And they used to think that the two big stars in Albireo were physically associated. I think they no longer say that, correct?
There's some controversy about whether they're just a visual double, because sometimes you'll see stars along the line of sight that are close to each other in the sky. I mean, is this star and this star, linked to each other? Are these stars linked to each other, or is it just line of sight? One is here and one is like many light years behind it. So that's possible that these are not anything but a visual double. But it's just, and it would kind of make sense, because a B8 star coupled with a K star doesn't really make a lot of sense, because you would expect the stars to be the same. Like when we look at Epsilon Lyra. Okay, the stellar components are similar to each other, because they formed at the same time out of the same stuff. So what would have to have happened here is that this particular B8 star is still thriving and doing hydrogen fusion, and a companion has stopped somehow. And usually if they're formed in the same region, the stars have similar compositions and they have similar lifetimes. This K3 Roman numeral 3 star is already on its way to its demise, and this B8 is not there yet at all.
Well, it happens.
It does.
I mean, we see the red giants in the left-hand cluster of the double cluster in Perseus, and
You do, yeah.
those red giants have evolved off the main sequence, while their companion cluster stars are still on the main sequence.
Oh, yeah. Genghis asked the question, could a black hole warp the image / double it? Gravitational lensing does different things. A gravitational lens wouldn't double the image. What it would do is it would actually stretch out the starlight, and you wouldn't see stars. You would see kind of like rings. See these halo rings here? If this was gravitationally lensed, you might see that this, instead of seeing a star here, you might see an arc of orange, and you might see an arc of blue, and then maybe another one on the other side sympathetically. So you might get that, but gravitational lensing is something that's actually pretty obvious, especially when you look at it with galaxies. The galaxies follow the curvature of the gravitational field around the black hole, and that's something that that governs and dictates the actual shape of the object. So if it was a star, the star's light would get stretched, and the star wouldn't be, but the star's light would be stretched and made into an arc as well. Okay, this is enough for Albireo.
Izabela's here.
Hi, Izabela.
Hi, Izabela.
Izabela told me before that she might be showing up tonight. That's nice. See that, Izabela? Everybody loves Izabela.
Everything is better with Izabela.
Everything's better with Izabela in it. Hey, I remember that. That was like the Blue Bonnet on It commercial. Remember that?
Oh, yeah. That's why I said it.
Okay. All right. Okay, so we're going to back out now. This. We'll leave Albireo alone for a little while. What I'd like to do, actually, is we haven't imaged this in a while, and this is just such a stunning object that it really merits a look. Every time we're in this region, in this area of the sky, I think it's really important to look at this faint wispy arc. Okay, this faint wispy arc is like an 8,000-year-old supernova that occurred. It's part of it. It's not even the whole thing. The other half is on the other side. It's a roughly round supernova arc, or supernova. And the center of this particular supernova is not visible to us, but I do believe it's Cygnus X5. And I know you and I talked about this before, Daryl, and I'm pretty sure that it's Cygnus X5, which is the designation for the black hole / pulsar that was left behind here. Isabel says, yeah, but I was dreaming a second episode of Carbon Stars, and tonight the dream was about stinky stars. I kid you not. My dreams are wild. That's great, Isabella. Wow.
Well, they say if you're out in space, it smells like
gunpowder or something, right?
Gunpowder, burnt steak, something like that.
Yeah. Okay, we're starting a 25-second exposure of what's called the Eastern Veil. I'll make note of it here.
Some people see an animal figure in the Eastern Veil here too.
Okay.
And I forget what they call it. See if I can find it.
And it's an SNR, supernova remnant. Look at that. Wow. We'll check our focus real quick, and then if the focus looks good, we'll leave it. Okay, focus. We will need to do again. This is beautiful. That's actually not even as good as it could be. If you want to see what it really looks like brightness-wise, that's what it looks like. Check that out. Okay. And this is wispy Nebula music too. Alright, I'll go back to 1 second here. And then we're going to do a focus run. Alright, so we'll come out here. And I'll take us down. Alright, so right from here, I'll go again a little bit.
Oddly enough, they call it the Bat Nebula.
This?
Yes.
Huh. Well, I don't know who's calling it the Bat Nebula, but I've never heard that.
I have.
Okay.
And I just found it again, too. Some people evidently see a bat in there. I used to see Alfred Hitchcock, but the nose is all wrong.
Sam S says timely music for the shot. Yeah, it was. I didn't plan that, but it was great. Okay, so we're building our focus curve here. You also notice I'm looking to the left and to the right. I got a big curved screen in front of me. The left shot is the observatory feed, and the right side of my screen is the broadcast feed. So I'm looking both directions. But when I'm looking to this side, I'm still looking over here at stuff over here. Like when I reference this curve. Okay, the curve is on my left side, but it's also on the right side. And here you see that the best focus point was found at the bottom of that parabola. If you remember your geometry. And it gets to the point where it gets the best possible solution, and then it'll either stop early like it just did, or it will proceed to go all the way to the end of 12 queries. Okay.
NGC 6995, the Bat Nebula, southern end of the Eastern Veil.
Oh, down here. Okay, then let's bring this up a little bit. Let's bring this up a little bit to bring that, because I think I have it just.
It was actually an APOD just a few weeks ago.
Okay. All right.
NGC 6995, also I think IC 1305.
Okay. Oh, so now I have that in here, and we'll see it now. Okay, let's go do this. This is gonna be fun. All right.
IC 1340.
Okay. All right. Let's get out of our low light mode and drop in. You'll see the previous image in the buffer that we'll get rid of. Okay, there it is. That's beautiful. And this is now going to be up a little higher. All right, so top of that eastern veil might just be out of shot a little bit. But it's okay. We're looking for the bottom of it mostly. Okay, so this is the bat you were talking about?
Somewhere down there.
All right. Okay. Let's pull in our curves. Let's darken up space a little bit. Go to the beginning of our curve, but not past the center. That's beautiful. Look at those colors, guys. So, this blue, this bluish green color is a doubly ionized oxygen. And the red is singly ionized hydrogen. Now, in the universe, the abundance of elements is very important. Hydrogen is the most abundant. Helium is next, because helium is the byproduct of fusion, initial fusion of any star. And then oxygen is the third most abundant. And the fourth most abundant is carbon, believe it or not. So it stands to reason that carbon and oxygen and hydrogen will all have a relationship with things that matter in the universe, such as life. And they do. So I'm prejudiced. I'm a carbon bigot. I think that if there's life in the universe, it's most likely going to be carbon-based. And that's because I don't see any other way. Carbon is the most flexible element in the entire periodic table. Most flexible of any element.
Me neither, Karen. I mean, people are saying they see the profile of a face, and that's what I used to call Alfred Hitchcock, but it doesn't look like Alfred Hitchcock. He looks evil. He's got a grin on his face, and
yeah, you're seeing this.
Yeah, he's got a pointy nose.
And you're seeing that. And he looks like he has an angry look in his face. See that? So he's got an angry look. Donald Kunzer says the Joker.
I think I heard somebody say that before. That's not bad, Donald.
It's Heath Ledger immortalized in the stars. Yeah, that's really pretty. Why don't we let me just get rid of this for now. And let's drop this out, and let's just go and maximize this view so you can see what we're looking at. Look at that. That's really pretty.
I'll be darned if I see a bat.
I don't see a bat. I'm already past bat. I'm going to turn off sharpening right now. Look at that. Interesting though, what we call the smile is a stream of material that's got this stream characteristic. And then we have another one down here. Okay, and that could be the bottom lip, this could be the upper lip, and this, the teeth and the bottom teeth, this then makes him look more like the Joker. If you see it that way, that looks like the Joker. Actually, it looks like the Cesar Romero Joker from Batman in the late 60s, on the TV show with Adam West and Burt Ward.
Yeah, I was trying to remember his name. Cesar Romero, of course.
Yeah, he was the Joker. Frank Gorshin was the Riddler. That's not this guy. Mr. Freeze. Remember Mr. Freeze? Horror King.
What?
He was the Horror King. Mr. Freeze in the original Batman.
On the Adam West version? I don't remember
Yeah.
Mr. Freeze.
Oh, yeah. Yeah.
What was the actor?
Vincent Price.
Oh.
Vincent Price was Mr. Freeze. Yes. And now, dynamic dunderheads, time to cool you off. Is this the end of our dynamic duo? Tune in next week. Holy ice cube, Batman.
Vincent Price was a cool guy.
Yeah.
He was a homeboy too.
Oh, that's right. Yeah, I think you told me that. You know, I did a submarine movie over in London, and we had to build these models and run them underwater in the special effects tank over there for the visual effects unit. And while we were there, they set us up in this one room, and it was at a very old movie studio over there. And when we set up in this room, one of the guys came up to us and said, "Do you know this room has special meaning? It's actually a very special room." And we said, "Why?" "Well, this was Vincent Price's dressing room." What? It was Vincent Price's dressing room. And it was like a little hole-in-the-wall room carved out of a wall. You know, it was about 10 feet long, 4.5 feet wide. It wasn't very long. But I guess it was enough for a person. So whenever he did movies, that's where he was... That's where he did all his makeup and got dressed and stuff.
Vincent Price was Egghead.
Oh, Egghead. I'm sorry. Thank you. You're right. Egghead. That's right. Exactly.
Yeah, somebody in chat mentioned it.
Yeah, and Penguin was Burgess Meredith. Yes. Yeah.
Really funny pictures of him online as Egghead.
I know. Can you imagine Vincent Price getting a skinhead mask and all that on? I just found it funny that Commissioner Gordon would say, "Egghead's on the loose again, Batman." Like criminals have these special pen names.
Sam says he thought Mr. Freeze was Otto Preminger.
He might be right. If I remember, Mr. Freeze was a larger guy, right?
I don't remember Mr. Freeze from the Adam West Batman.
I think he was in there. Who was the guy? There was one. Oh, it was. I think it was Riddler who would always or sometimes have Simon Says jokes.
Mr. Freeze, he was played by 3 different actors: George Sanders, Otto Preminger, and Eli Wallach.
All right.
I certainly don't remember that. Of course, Arnold Schwarzenegger played him here in the movie.
Yeah. In the later remake, yeah. Hey, Lucky Luke, what's up? Nice to see you. Yeah, you're right. If we tip the face, we can see another. We can see another face if we tip the image. Very cool. All right, so we are up to 20 stacked images here. Now let's zoom in now on the thing that's supposed to be a bat. Look at that beautiful stuff, though, guys. Now, this shapes that we see here. Now, we see that top curve. We see a second curve. And we see a third curve. So what's making those spindly structures in there? What's making all the really interesting lacy work here? There's some theories out there now. Is the fact that there might be electrical charges flowing through this object and through the gas and dust. And so now the question is to what's making it glow. Cosmic Ray asks, okay, when this stuff is moving out, it's moving away from the source of the explosion. Now there is an initial heat that's going to be generated and maintained for some period of time, and of course there's a very energetic dead star left behind. And as I said, I think we're talking about Cygnus X5, and maybe you can verify that, Daryl. I think it's Cygnus X5, but as these move out, they're striking other debris in the interstellar medium, and that in part shapes what we see. Otherwise, it'd be a perfect sphere moving outward, but it's not. It's all this filamentary stuff, and when it's striking this material, it's hard to follow this, but as it strikes it, it can get heated to millions of degrees, and so it's going to cause the ionization in here. Yes, along the way, some stars, they might encounter some stars that are going to cause some ionization. It may, right? Or it may, just because of the impact in the interstellar medium, striking all the dark material that's there, the dark dust, it may heat this material, this gas, to this very high temperature, which will cause it to ionize. And again, the bluish green, that's the oxygen, and the red is the hydrogen. You know, it's really beautiful. I'm going to re-engage the unsharp mask. Okay, now you see all these subtle details in here. All these subtle details could be driven and shaped by the nature of electrical charges running around in here. That's something that is very, very possible, like right here. Okay, this little guy right here, that might have electrical charges in it. This shape right here, this arc right here, is a very particular kind of arc. You know, maybe shaped by electrical charges that are moving around inside this gas, this expelled gas, which is also very, very hot, and which is also probably going to be charged, because if it's very, very hot, that means that the electrons are no longer on the atoms, and that means they're ionized, which means they're positively charged ions left behind, the protons in the nucleus. So this is something that we would see in the universe all the time, is that ionized material is going to be charged material. You also have free electrons roaming around, negative charge, okay? And these are also going to be out there running around and participating in potentially shaping this nebula the way we see it. Let's go down the bottom here and look at this again, because we're now getting, we're up to 30 stacked images, so we're getting a lot less noise. All right, so let's do that. Let's zoom in more than we should, but let's zoom in on this knot of really interesting activity here. Yeah.
I found one image that says sort of the bottom right-hand corner of the mouth we see there is IC 1340, the Bat Nebula.
I mean, there's
the bottom right corner of the mouth, or the chin.
So this here?
Bottom right.
This is bottom, this is right.
That right there.
That's the bat, huh?
Supposedly.
Okay. Batman, da 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 da. Okay. But I don't see it.
Me neither.
Oh well.
I don't know. Other images I saw. Well, no, I'm not going to say that.
I mean, this looks like a seahorse in neon, doesn't it? Look at that. So these filaments, they have a life of their own. Possibly generated by electrical currents flowing through these nebulae from the ions. So it's just something else. Really, really pretty. Now you might say, look, it's getting very dense up here. Well, keep in mind, we're looking at this in 3 dimensions. So we could be seeing the curve, the edge of a shell. And as we look through the edge, you see how you can't see my fingers, can't see through them. When you get to the front, you can see through my fingers. When you go to the back, you can. But along the edge, it's thicker, and you can't see through all the extra stuff there. You're looking through more material as it goes around the corner. So this could be part of a spherical shell. All right. We're going to save this now. Save exactly the scene. Let's bring the telescope back. Alright. And let's re-engage redock our stack there. That's pretty cool. So we have we're gonna have 37 images that are stacked here, and we're going to, like, those are considered low numbers. Typically, you can go to you could typically go to like 100 or 150 of these. You know, you can do that. One second. Good to see you. I'm streaming. Sorry. Okay. All right, so when you look at this, this is just going to be, now we're at 38, so we'll just save it there. The more you stack, the less noise you'll have. So it actually looks pretty good right now, so we'll save it right there. And what I'd like to do is show the middle of the veil. I think that's what we'll have time to do right now. Unless you got any other ideas.
Pickering's triangle.
Yeah. So we'll zoom in here. So here you can see the overall shape of the veil. This is the spherical place. You can see that the star that blew up was probably somewhere in here. Happened around 8,000 years ago. This is like 1,500 light years away or so, which is why it's so big in our sky. And different elements of this have different features that people will notice. Like this part right here. This triangle is known as Daryl just said, Pickering's triangle, and we're gonna go there now. And it's just a little bit to the west of that other eastern veil segment.
Stan says your music's a little loud. That's what Stan says.
Thank you, Stan. Okay, I gotcha. All right, so we'll do a 10-second shot here.
jog it down just a touch.
Excuse me. Yeah, actually, it's already. See what I'm seeing?
Okay.
Yeah.
There you go.
The frame is actually included. Let me just zoom out a little bit so you can see it all. And this is the western veil right here, the tip of the western veil. Eastern veil is out past this. It's a little further out. So. Hey, Louis, how you doing? That's correct. I think it's 2024. Is it 2024 PT5? The asteroid
Something like
that we're gonna capture for a short period of time. Yeah. I looked up the size. It's just like 33 feet across or something, and it's gonna be far enough away that our telescope would not be able to see it.
Interesting how the red hydrogen and the blue oxygen are so separated in the triangle. Distinct areas.
Yeah, I imagine that separation is actually a separation based on density and the dominant gas in that particular locale. In other words, there's hydrogen and oxygen in here, but the density of hydrogen is higher, so the hydrogen is what you see. Here, the oxygen is more dense. That's kind of what I'm viewing. But there's hydrogen and oxygen throughout all of this. It's just that the dominant emission that you see is very easy to overwhelm one or the other with the density, the higher density. So that's why it looks like this separation in many of these nebula. Like, okay, here, okay, if we zoom in on this, okay, this, you see there's a mixture going on right here. This is kind of mixed, you know? It looks mixed. But Daryl is right that you can see the different distinctive colors, but they're interspersed with each other. So, like here you just see some oxygen, but there is some hydrogen in there too, and it goes like this through this whole region. You don't see it that much because it's not as dense as the oxygen is right here. That's it.
Stan Two Rivers has a question for you.
In your histogram, what would cause spikes to the left of the large peak? Let's go see the histogram. Well, we have, you notice how it gets more turbulent down here, because at this end, Stan, on this end, we're seeing noise affecting our image, and over at the left, that's our signal, and that was the noise. So we want, let me just dock this for a minute. I know I haven't talked to the left yet. I'll get to that. But as we move further out, okay, you'll see this histogram change shape as we get more exposures, because we're pushing the noise further and further down into the background. And so it's gonna, these turbulent areas are going to get smaller and smaller and smaller. Ideally, we want a perfect curve all the way down here, but we'll never get it. All right?
Can you show farther to the east, farther to the left of the sharp peak?
Well, that's like this. There's nothing out there.
He says he saw sharp spikes to the left of the sharp peak.
Yeah, that, as far as seeing spikes to the left, those spikes could have been noise or, a signal, a noise that wasn't part of the main signal. And as soon as you take more exposures, it refines the overall curve. early on in the process, you'll see all kinds of additional noise, and now our curve is actually fleshing out here. And as I say, 12 exposures later, okay, our really bad noise is way down here, whereas it was much closer early on. And as the noise is subdued by the addition process, image to image sandwich, we lose a lot of that noise. So we care about what's to the left of this yellow curve and what's above it. You know, that's where we're playing right now. Okay, let's actually get rid of this. Get rid of my telescope again for a minute, and let's move this out of the way for now. Come out. There we are. So now we can see the whole triangle region, which is in the center. That's really nice.
As for the name Pickering's Triangle, as Mark left that out there a while ago, Pickering was the director of the observatory, supposedly. Pickering did not discover Pickering's Triangle. The schmo working the night shift found it, and Pickering got the credit. That's just a story. I'd have to look that up. Ray's asked a question a couple of times. Is there any experiment on Earth that can show high-speed collision produces ionization and light emission? Sure, Ray. It's called a neon sign. You don't need a tokamak for that.
Yeah, that's actually a very good example.
They actually use different gaseous elements in neon signs to produce different colors, and it's as simple as electricity and gas. And the different colors are the very same thing we're seeing here. The very same process, that is.
Yeah, I actually have gas tubes that I use when I teach spectral classes, spectral analysis. And with a grating, just hold in your hand, you can see the emission lines of, say, mercury, hydrogen, helium, and other sodium and other gases, and you can see the emission lines, for instance. And that's what we're seeing here. We're seeing the hydrogen alpha emission there. But I noticed something, Daryl, and to your point you've made a number of times, and I think it's really interesting. Look at this. This looks like a very faint line of stars.
Yep.
And it looks like it goes down here. So I wonder if these stars, and it continues here. I mean, that really is an eerie looking line.
Well, those stars by definition would have to be older than the nebula. So chance alignment, or could some force of the supernova have, the turbulent cloud have caught up the stars and forced them into alignment? I don't know.
I don't think so, but I do think that there is a possibility that a shock front could have created some stars. But if this is only 8,000 years old,
exactly,
this would be odd to see stars formed here as a result of the supernova. they would be very hot young stars. And if this is only 1,500 light years away, these stars would be very, very bright. They'd be like bright as this, you know. Let's see what our annotator shows.
Interesting thought.
Okay, so it just covers the whole remnant. All right. It doesn't do anything specific. Yeah, let's try going in here for a minute. And let's go back to Pickering's triangle. Okay, well, we have better resolution than Stellarium does. All right. Let's do this. All right. And this will be... I know right where that is. Okay, we're going to come here. And we'll say a line on that, because that's actually pretty close. And then grab this, center on it. And that should give us what we see here now. Alright, so what we'll do is come out of here, and we should see this guy over here to the same extent as we do, and we do. That's really pretty. Really pretty. Alright, we have 28 frames here. Pickering's triangle. And this is the western veil. I guess we should do that one as the last object, don't you think?
Sure.
These might actually go together. We might have had enough to actually link this one to the previous image. I should probably change this to central veil, because I didn't save it yet. Now I'll save it with 30. Beautiful gossamer strands. Absolutely stunning. Okay. Yeah. Let's bring the telescope back. Alright. Okay. Nice. Okay, this will be up on the server in just a few moments. And we'll get rid of you. And enter low light mode again. Alright. Low light it is. And now we're going to head down here. And all I'm going to do is move the telescope, because that's all we have to do, because we see where we're going next. There's a star in the foreground named 52 Cygni. It looks like it's in the nebula, but it's not. And we'll move to the west a little bit. Maybe just a tad down. Do a check ride. We're going to say 5 seconds here. And see what it looks like. I think the tip is just off there, but it's actually, we have it. Yeah, the tip is in there too because it's up top. Right up there. Cool. All right. So once again, we're going to do 25 seconds. And head into our deep sky mode. So from the central veil, as it's called, we will move. What?
Oh, I was muted.
Oh, sorry. And this will be the western veil.
I was wanting to give some foundation to that story about Pickering's Triangle.
Oh.
It was discovered photographically in 1904 by Williamina Fleming after the New General Catalog was published. The credit went to Edward Charles Pickering, the director of the observatory, as was the custom of the day. So Williamina got ripped off. Anyway.
Yeah.
Damn, man, they're all like...
Yeah. And Cosmic Ray is making a notation about the illumination of a neon sign and so forth. It has to do with electrical charge in the gas. And so if this material is going through space and it's electrically charged and it collides with other material, it is going to raise the temperature by quite a lot, and it will ionize and it will glow. However, as far as what experiment you could do here on Earth, I didn't understand your question before, Ray. Sorry. We do gas experiments, and we know that gas has a certain ionization potential, and we know that we can generate light upon atomic collisions, and we'll see that in particle accelerators too. They generate energy, electromagnetic energy of some kind. Whether it's in the visible spectrum or not depends on the energy of the collision. But when you make such a collision, you will get a result. And that result is usually going to be, it can be in the radio spectrum, it can be in the visible spectrum, it can be in the high energy, high frequency spectrum. But you get a result that's electromagnetic as well. And that we do it all the time at the Large Hadron Collider, for instance.
Is it bright inside the Large Hadron Collider?
I don't know, but I think anyone that could look in there would probably be dead.
Yeah, well, there are stories about things like that.
That's true. That's true.
Some guy stuck his head inside a particle accelerator,
yes. Oh, yeah.
His hand or something. I think maybe somebody lived and somebody didn't. I forget the story.
He was in the way of a particular beam, and it went right through his head. But it didn't poke a hole. It didn't do anything to his head physically. They left a mark where it went in, but it's like getting a massive X-ray, with say 100,000 times the dosage, and hitting you in a very targeted, focused point. I think he lived, but I think that he had issues. I mean, if you stick your head in an accelerator, you have issues anyway.
Yeah. I bet he saw Christmas.
That's right. He probably also saw all kinds of lights in his vision. So this is the Western Veil, guys. This is the remains, the central veil that's up here and then spreads into that beautiful triangle up above up there. And down here at the bottom, you can see there's some more just in sundry material floating around here. this beautiful tendrils, and Daryl has likened this to like a tornado. It looks twisted, and it may very well be. It may be tendrils of material that were spewed out from the center of the supernova explosion 8,000 years ago.
Anti-M.
Yep. Again, this star is 52 Cygni. It's way up here in the foreground, and this is way back here, this nebula. So it's just a happenstance. It looks like it's there. Yeah, let's shrink this down just a bit so you can see everything. I'll zoom. I'll fit the width, fit the height.
Yeah, I don't know about a tornado, but I mean, you can look at the entire Veil Nebula, and it's obvious there's a lot of very turbulent things going on.
Yeah. And as we've talked about, as this gas is expanding outward, in an ideal universe that had nothing in it, it would expand in a perfect shell. You know? Because a supernova is pretty homogeneous in the core collapse, because it initiates in the core. And just before the final shock wave, there is a burst of neutrinos that are released from this core collapse in a massive star, and those start to shoot out, and it's all of the interactions with all the rest of the material on the way out that actually causes the shock wave to start heading out of the star. And the neutrinos are traveling at light speed and are relatively unimpeded. As I said, 1 in a billion sounds like it's pretty impeded, but it's actually not. And so 1 in a billion neutrinos get out, and they'll show up in a stream, and we'll see in our neutrino detectors that we have around the world, we'll see, whoa, we just got a burst of neutrinos from the upper left part of Orion. Betelgeuse is going to blow in a few hours. We're going to see it visually in a few hours. And that's because the neutrinos get out long before the matter itself in the shock wave can expand and push its way out of the surface of the star. And that's what the supernova does. So the neutrino burst is the precursor to the physical material that's pushing outward from the core in that outgoing shock wave. So if we see a neutrino burst and then we look at Betelgeuse, it might look normal. It might look just fine. In fact, it would. And so we'd have to watch it, because Betelgeuse is large, very, very large. You would have to sit there for a number of hours waiting for that shock wave to breach the surface from inside. And when that happens, you will be in the front row seat to watch Betelgeuse light up your daytime sky as well. So right now, Orion is rising. At like 3 a.m., you'll see Orion rising. And during that time, if Betelgeuse were to go off, we wouldn't know it unless we captured the neutrinos first, and then we could wait a few hours and then watch Betelgeuse just go really, really bright in our sky. And it would stay there for weeks.
Betelgeuse is rising about midnight now, if I remember correctly.
Okay.
Let me check.
You might be right, because I look at it from here.
Yes, it is.
3 hours distance. So it's about 3 a.m. here that it's rising, but that's midnight at the observatory time.
Heavens above at 12:33 a.m. Orion is pretty much up, except for Saib at the lower left-hand corner. And actually, that would make it 11:30 Arizona time, but then depending on where you are in your time zone, it wouldn't be 3 o'clock. It would rise roughly at midnight, even in Connecticut.
No, if we see it rising in Arizona, right? It means it's midnight in Arizona, which means it's 3 a.m. here. At that exact moment, if it's rising, yes, it'll rise at midnight. Connecticut
It'll
time,
rise about midnight anywhere.
but the Connecticut time.
When it,
Go ahead.
it rises. It's rising at 12:30 here in Colorado. Arizona's about a half an hour after us, so call it 1 o'clock, but then take away the hour of daylight savings time, and it would be rising right about midnight. It would be up for 3 hours already in Connecticut.
Yeah, that's where I was going with this. I was just, it's whatever time zone you're in, it's still rising at midnight for your local time.
Yeah.
But the thing is, if we see it rising in Arizona, okay, like right now, the time in Arizona is 9:30. So we have another 2.5 hours before Betelgeuse technically rises in Arizona. But if we were doing this until midnight Arizona time, my clock would say 3 a.m. and that's when Betelgeuse rises in Arizona for me, because I'm in Connecticut. For you, it rises at 11 Arizona time for you, because you're an hour ahead, I think.
We're both in the Mountain Time Zone, but I'm on daylight savings time and Arizona's not.
Yeah, it's really strange. They don't do that.
But then you're also farther west in the Mountain Time Zone than I am, and what happens at midnight here would happen at 12:30 in Arizona, like a given star rise or whatever, if you do not count daylight savings time.
Mm-hmm.
Michael Hedrick has a question for you. It's a fun question.
No, sir, he's not fun. Okay, could you tell us, please, what would be the sequence of events, actions that would that you would take if Betelgeuse went off while you were sleeping, or if you got a notification in the middle of the night? Well, Michael, the first thing I would do would be I would get up and I would run down here and I would open the observatory and I would start taking imagery of Betelgeuse and get some data, short exposures, long exposures, and try and get as much data as I could. If we had the other telescope up in Benson, I would do a spectral analysis of Betelgeuse as well to see if the spectrum shows any indication of other elements breaching the surface. Because if we see the supernova, the shock wave has breached the surface and the star is in the process of ripping itself apart. Remember, this is a star that's almost as big as the entire orbit of Jupiter. So this star would take a long time to just explode and move outward. It would take some time.
It wouldn't reach peak brightness for probably, I don't know, days at a time, days yet, would it?
Oh yeah, and it would be months before it actually, cooled off enough to dim out. We've seen supernovae in other galaxies. Remember, they're blue when we first see them, and then they get redder as time goes on. Weeks and weeks and weeks.
Yes.
Hey, Red Angel. Red Angel's with us.
Along that line, Michael, there are hotlines in astronomy. Alerts would go out across the world, and amateur and professional astronomers, and probably a lot of amateurs too, if they're hooked up, they will get a notification instantly once it goes off, I assume. As Mark said, if they see the neutrino rush first, and they could pinpoint that it was in Orion, that would give them a little bit of a head start, because the visible supernova won't happen for a while yet, hours if not more, and hopefully people would be ready for it.
Yeah, but the nice thing is, even if it happens in our daytime sky, you'll be able to photograph it. because you'll see it in our daytime sky. Betelgeuse is, let's say, it's hard to get its distance, 500 to 700 light years away. I've heard 450, I've heard 750. So let's say it's 500 light years away, okay? It's close enough so that if it went supernova, you would see it in your daytime sky. When the Crab Nebula was made, that supernova, all right, was seen by Chinese astronomers. And that supernova was visible during the day. And it wasn't the star that was anywhere near as bright as Betelgeuse, or anywhere near as close. So Betelgeuse would stand to be a second star in the sky, which would be pretty interesting. I'm kind of interested in seeing another star in the daytime sky, to be honest. And Betelgeuse, if it's in that transition of the seasons, we might be able to see Betelgeuse as a late night star in the sky, or perhaps a object in the daytime sky as well. It'd be pretty cool.
What are you looking for?
I'm just trying to find out whether we can do one more object. I have time for one more. I said I was going to make this the last one, but I lied.
All right. Will you excuse me a moment then, please?
Yes.
Right back.
Yeah, we're going to be looking. It's hard to let a good night go to waste, guys. I just can't. Right, so let's go down here. No, not here. Get back out of it. That's Lacerda. Here we go. All right. All right. This is by far one of the most interesting nebulae. And we'll check that out. And that'll be our last object for tonight. We'll save this. Save exactly as seen. And now we have a complete view of this supernova remnant. And we'll be back to that. We'll make mosaics and get it to you if we can, so you can see what we're talking about. I'll put it in Facebook and so forth. All right, and now let's go here. Low light mode. Low light. And now let's move on up to the north a little bit more. We're heading to an object called the elephant's trunk. This is a stalk of dust, which is really quite an amazing sight. And it's right about here. So I'm going to head a little bit north. And then I'm going to head a little bit west. Alright, go more west a little bit. Go west, young man. Okay. And I think I want to go up a little bit. Alright, so right there, I'm going to do a quick 5-second shot just to verify what I think is the region. I think it's right here. Okay, that's the... yes. Alright. Very good, okay. so we're going to move just a little bit more westward. And
what are we looking for?
Elephant's trunk.
Oh.
All right. So we'll get out of this in just a minute. I'm going to take us now to 25-second shot of the elephant's trunk. Telescope just went through the meridian.
I see it already.
Yeah, it's right there.
Yeah.
Yeah. So I'm going to want to move us over just to get the caravan.
Cepheus, right?
Correct.
We should try the seahorse again and then swing over and shoot whatever that is to the left of it. I forget offhand. It's a big bright nebula.
Yeah. So you're going to see this stalk right here, and you're going to see a lot of detail here, which is going to drop off over there, which is kind of neat. All right, so 25 seconds. We got 25 seconds on the clock, ladies and gentlemen, and off we go. And we'll go into our deep sky mode, and you'll see the previous image that we took of the western veil. Gosh, that's beautiful. So we'll clear that now. And you'll see the elephant's trunk. And you're going to see a rather fascinating object. I'm going to check the focus too in our first shot. Cindy.
Thank you, Cindy.
Thank you. That was very nice. Okay. Thank you, Cindy. That was very, very kind. Okay, focus is good. This nebula is fascinating because it exhibits a number of characteristics that we see and processes that we see happening in the universe. Among them, and this will make itself evident shortly, this is a dust cloud, right? And the dust cloud has hydrogen gas, which is being ionized by hot stars nearby. And this star in here, a younger, a hotter star, has excavated a hole, a cavity, around, around this middle area. And it's pushed away some of the gas and kind of cleared an opening for itself. And you'll see it as this progresses. You'll see it. All right, and so there's a lot of detail in here, a lot of weird stuff going on in here. Let's color correct first. That'll help with our colors. Okay, already now we have 3 images. You can already now see the structure here. Really something else, and we have more that we can look at, by the way. So now you see the whole thing.
Those humps to the right of the elephant's trunk are called the caravan.
That's right. 1, 2, 3. Yeah. And now
They may be referring to camels. I'm not sure.
I would think they are.
Looks like camel humps.
They do.
1 hump or 2.
Isn't it the camel has just 1 hump, a dromedary 2?
I think so. The name escapes me for the regular camel at the moment. It has 1 hump.
Bactrian.
Bactrian, or no, is that the other way around? Dromedary is the single hump camel, and the Bactrian camel is the one with 2 humps, I believe.
Okay. I always wanted to ride on a camel, but a 2-humper, so that I could ride in between them, so I have something to hold on to. Because they're pretty nasty animals sometimes. They spit and they actually bite. They nip at you. I mean, I guess I would too, if I made to walk in sand with, tourists and stuff like that all the time.
Dwayne Johnson had a pretty neat camel in The Scorpion King.
Oh, wow. Thanks, Fantasy. Camel in Arabic is Jamal, if you were wondering. And he says camel is one hump. Okay.
Whichever, again, I think it's Bactrian. It's the camel over in like Mongolia, more in Central or Eastern Asia, has two humps. It's like the cold weather camel, if I remember correctly.
I guess with two humps, you could store more water. Right?
I suppose. I know they're they're in like a high desert, and it's very cold and dry there.
Look at this coming through. You can see, guys, more detail making itself evident here. We have an unsharp mask on here, so we are sharpening a little bit. If we take that off, it'll get a little bit more muddy looking. Okay.
Yeah, the dromedary has one hump. Bactrian has two.
Okay.
They actually store fat in the humps, not water.
Right. That's right. That's right. Well, I'm not a camel specialist. That's cool, though. Let's do this.
Donald says, Mark, your mic is breaking up.
I did just move it. Well, let me know what it's doing. This is looking good here. There's our camel caravan.
Or maybe it's an elephant caravan. I mean, looking at the elephant's trunk, going back, it looks kind of like the knot on top of the elephant's head and a hump behind it.
Yeah, I'm not sure. Not sure. Not sure at all. I do like, though, how this is looking. There's some dark nebulae up here that you can see. If we move over, you'll see there's a very dark area right here. This area is rich and replete with dark nebulae in here. And then if we zoom in on this central portion here, you'll notice you can see that star that is actually carving out that open interior. Let's take this off maybe to make it more obvious. You can see these deep filaments in here.
When you look up towards Cygnus, it is a very dense starry area, and just a little farther north than Cygnus, I guess you'd say, is Cepheus, the king. Cepheus is a very dusty area.
Okay.
Seen a lot of long exposure, deep images of Cepheus, and it's just absolutely jam-packed with dust.
Okay. This is really pretty.
Fantasy, I'm sure you know this. You get over in Saudi Arabia, they have beauty contests for camels over there.
Doesn't make the camels any nicer. Let's see if we can pull a little more detail out here. This is called a push, where we actually move these lines closer together. We're pushing, doing a push processing. And we'll zoom out for a minute. And to see what else is in here, let's actually pop up this histogram as well. And now you can see that there's some real complexity in here. All kinds of stuff in here. And we can see most of it right now, actually. Really nice. Wow, that's nice.
Yeah, the dark stuff at upper left is a nice touch.
Yeah.
That one big blob is coal black.
Yeah. Hey, Timmy de Spain. How are you? Nice to see you. If you guys haven't, if some of you haven't subscribed, please do. Everything we do is free, and I don't think there's a whole lot of this going on out in the internet. You know, where you have astronomers telling you exactly what you're looking at in the sky and then show you different objects and then give them to you for free. At skytourlive.org, you can do all kinds of things. You can go to our Etsy store up there, Etsy at the SkyTour shop. And we've taken these objects and put them on everyday items like water bottles and mugs and blankets and sneakers. Yes, sneakers. And mouse pads and shirts and beyond. I mean, we have coasters, playing cards. We have all kinds of stuff up there that you can get at our Etsy store. It's called SkyTour Shop. Check it out. I've made about 100 products, but we have about 45 or 40 active ones. So that's the cool thing. And I think that if you take a look at what we've done, I think you'll probably like them. You know. Okay, and that's SkyTour Shop. If you go to skytourlive.org, you can also join our Patreon up there, as well as just look for us on Patreon. We'd love to have your support in Patreon. And if you don't want to support us at all in a monthly thing, well, you could certainly just go to skytourlive.org and click the donate button and help us and help support us. We would love to see you as a Patreon member, though. Being a Patreon member has benefits. The higher up the tiers you go, you get images like this one, fully finished and fully processed, all the way up to the highest tiers where you get your own SkyTour and your own private processing done for you of any object you want to see, or if we suggest an object. We've had people do that already, at least one person. So I think that's pretty cool, and I would hope that you guys would think about that as well. So think about our Patreon. There's $3 all the way to $200. I know people say $200. Yeah. So we have it, but we're not making any money in this. We're not taking a cent. All the money goes into giving you a better experience. And I know that's a typical crap you hear, but that's not true in our case. We don't do any of this crap. Okay? We make the experience better for you, and that's all we do. Daryl's not getting anything. I'm not getting anything. We are getting richer by just being able to show all these beautiful objects out there. And that's just what we're doing. We've got one more here to get to 30 in the elephant's trunk.
That'll make a nice picture.
It will, with all this extra stuff out here, yeah.
Yeah.
And it goes down below a little bit. See, so that's a big, beautiful picture. You can also buy prints of these, get prints that are on glass, under glass, on metal, and you should see our wall at the SkyTour home base in Mesa, Arizona. I'm in Connecticut. The telescope's 2,600 miles away from me, but in a home base in Mesa, Arizona, you can actually see the gallery of all the photos and stuff on the wall. You get canvas prints, framed, not framed. They're just incredible. It's amazing how far we've come in, was it 5 years, 3 years, 4 years? We've talked about this.
You started in 2016, I believe.
Yeah, maybe.
I came around in 2016 and sort of joined SkyTour in 2017, I believe.
Yeah. Absolutely. So, we are approaching the end. I'm going to save this one more time. And I'm going to save exactly as seen. And then I'm going to try an annotation, see if it knows anything in the view here. It knows this Hipparchus star, which is fine. It doesn't know too many actual objects, but it knows enough to get us around. Fantastic stuff. Wow. It's like I don't want to stop exposing, because the more we go, the more we do, the better it gets. You can see how this looks like this dark nebula here. It's very stranded down here. And you'll see that it actually has like these strands of material reaching out to this thicker area here. Like one thick strand and a thinner strand. Very, very much. Very, very cool.
Ray has a question.
What's his question?
How much exploring do you do? That is, imaging areas that don't have known objects.
Well, I tend to explore some known areas with folks because they're watching from all over the world. So I tend to give them something to enjoy. When I open privately, I very often image areas of the sky that don't have anything well known, just to see what's there.
We did a lot of exploring back when...
we did.
Oh, you lost your go-to.
Yeah, we couldn't locate it. Yeah.
And we just went out and randomly explored the sky a bunch of nights. We would go east until we hit the Milky Way, and then start going north along the Milky Way and along the Great Rift and stuff like that. Saw all sorts of stuff.
Yeah. Timmy Despain, thank you. That's very nice of you. Thank you very much for offering the compliments. Tiffany Echo says, I got STLS shoes. And she did. She got sneakers that are SkyTour shoes. They're really cool. Actually, when I do talks, I speak all over the world. And when I do my talks, I'll actually wear a pair of the SkyTour sneakers, which are really cool. And I can tell you this, people remember them. You know, they're not like clown shoes. They actually are very elegant in their design, but they have this beautiful imagery on them. Okay, we got up to 40 now. We'll save it. Hold on, let me get out of this. Did it save it? Okay, there we go.
You need to name it first.
Oh, very good. I should have. All right, yeah. I'll move it out of Western Vale and I'll put it in the elephant's trunk. Thank you. Hair Juicer 3000 randomly found the stream on Rumble. Suggested. Excellent. Well, thanks, man. It's good to see you here. Make sure you subscribe to us. And we just we'll hang out. I'm an astronomer. Daryl's an astronomer. We end up showing people the night sky, but we also talk about what we're seeing and where these things come from and how they form. And this is all real time. This is, as we say, the universe live in real time. You know, so you'll see a satellite come through sometimes. Oh no, you know. Right now we're doing a 25-second shot, and this is the progress bar down here. And then we stack them on top of each other to make a stack to actually alleviate a lot of the noise. We've done this 43 times so far here. Total exposure, 17 minutes, 55 seconds. What that means is, if I took one photograph and I exposed it for 17 minutes, 18 minutes actually, this is what we'd see.
Change your title.
Yeah, I will, but I'm going to do it after, because if I do it now, it's going to complain, because I already started saving it in there. So I have to wait. Alright, let's pop out here. And let's go check this out. I want to look at this up here. Look at this beautiful dark nebula up here.
That's cool.
It's actually... now the thing is, when you see very dark area, this is dust in front of this star cloud in this nebula here. And if it's really dark, it means it's very dense. So that's actually a characteristically dense area. Here's another one. Here's another one. Okay, these might gravitationally condense into a cluster of stars. Now, it's only dust in here right now that we're seeing, but there's definitely hydrogen gas in here. And so if there's hydrogen gas in here, that can condense and form stars. And then the dust might get pushed away a little bit by the stellar winds, just like we look at here in the middle of the elephant's trunk, which is right here. Look at that beautiful circular area. That's what we call a cavity in astronomy, created by this star and its stellar winds. Its solar winds, its stellar winds are pushing material outward in all directions, and therefore it makes a spherical cavity around its birthplace where it was born. It's neat. I mean, it's like a forensic study when you look at the universe. And we're always looking at the universe as it was in the past. And it's never just one past. Every single star in here is at a different distance from us. So we're seeing it at a different time in its existence. Very, very interesting stuff. Okay. At 50 we quit. So we'll go to 50 exposures. We're at 49 right here, as you can see. And then we will park the telescope after this 50th exposure, and we will be done. And I will show you the park process. We'll park it together. All right, so we'll save it now. Save exactly as seen. And say goodnight to the Elephant's Trunk Nebula. But it's been saved, so you're going to get it. In fact, if you go to skytourlive.org right here, and you go scroll down and say, take me to cool pictures, you can go and get this picture right here, right now. Right? It'll be up there in about 30 seconds. All right? And so you'll be able to take this picture down. Now, if you want to join the Patreon, then what will happen is we will process this, hyper-process it, to make it look even better in ultimate detail. Pick out all the data and show it to you. And that'll be good if you join the Patreon. Otherwise, this one's free. You can take it down now. Okay? All right. So we're out of here with this. So let's go back to our 1 second low light shot. This is our low light mode that we use in order to see the sky and find things. Kind of like a finder view. All right, and now over here, this is our telescope, and I'll just enlarge this for a moment to show you. Let me do this. Where is it? There we go. All right. All right, so there's the telescope out in the building right now. And what we're going to do is park the telescope. And that is the first step in closing down for the evening. You'll watch the telescope move around and swing itself down into a park position. And you'll see the stars moving correspondingly. This is a telescope that's 2,600 miles away out in our observatory in the middle of the Arizona desert. Okay. Now, as I mentioned to you before, okay, and it's when it's parked, it's going to be, it's going to tell us it's parked, right? I mentioned before that if we zoom in here, you can actually see that our telescope has this camera on the front end of it, right? And that's attached to a lens. All right, then there's a glass plate in the light. This is the guider scope, okay, and the secondary guide scope. These are what guide, and this telescope, and here's the camera that's imaging. It's very different from what you think about with this stuff. Hey, Proficient, how are you? All right, so that said, we can now come back and go back to our magnified view, or unmagnified view, and we can shut off the telescope. I will do this, shut off the telescope. Telescope is now shut off. Power has been disconnected from the camera, and now we will shut the building. So here we go. So now I'm shutting the building down, and we're going to bed for the night. There we go. All right, guys. Well, hey, you know what? Thank you for joining us tonight. We'll see you on another beautiful night in the Arizona night sky. Right now, we're heading down a spate of very good weather. So we will let you know what's going on. All right, and keep in touch with us. Please subscribe, and then you can get information on the community tab. You can see all of our. You can join the chat and enjoy us and hang out with us, ask questions. I'm always available. So hopefully that will give you a strong motivation to hang out with us. All right. So you guys have a good night, and we will see you later on. Good night, everybody.
Good night, all.
All right, guys. We'll see you.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Fill the lens a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. SkyTour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. SkyTour is bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. SkyTour is bringing the view,